Okay, now let's move on to example 2. Okay, from page 102. On page 102, example 2, we're finding the derivative of the function f of x, function of x being radical x, the square root of x. But we're going to be using the alternate definition to find the derivative of this. What is the alternate definition again? It's the limit as x approaches a of the f of x, function of x minus the function at a over x minus a. And then we could quickly change that for this particular example to be radical x minus radical a all over x minus a. Okay, we could change that. Again, we cannot substitute a in place of x at the moment. Okay, and it's not like we could factor out the numerator to be like the difference of two squares. I guess you could treat the denominator as a difference of two squares. But okay, one technique that you could use that we should be used to is rationalizing either the numerator or the denominator. In this case, we will rationalize the numerator to try to get rid of the radicals on the top and then see what that does to our whole expression. So you multiply by radical x plus radical a on the top, and you have to do the same thing on the bottom to maintain the same fraction that you started with, same expression that you started with, just in different form. So go ahead and simplify what's on the top. You could use the FOIL method to simplify that. You could do it mentally if you wish. Radical x multiplied by radical x will give you x. Radical x multiplied by radical a would give you radical ax. You can multiply the contents inside the radicals. We call them radicands. And then negative radical a times radical x will give you negative radical ax. Be careful with that sign. Negative radical a multiplied by radical a would give you negative radical a squared, which would just become a, and then all over. On the bottom, keep it at that. Okay, don't multiply that out, or don't simplify that yet, because we might be able to cancel out with what's left on the numerator. So you get to this point, and then let's see what happens. Then you could cancel out the radical ax on the top with the radical ax. So as expected, okay, we have something to cancel after that step. Okay, it's becoming nicer. So the x minus a's will cancel out, and before your final step, okay, it looks like the expression that's left is 1 over the square root of x plus the square root of a. So you have that. And at this time, you could substitute a in place of x. So you end up with 1 over radical a plus radical a. The limit notation is no longer necessary. And then your final answer would then be 1 over 2 radical a. Okay, so that will be the derivative of f of x equals radical x. And then knowing that, okay, we want to apply this to any x for the function f of x, then your derivative could be written as 1 over 2 radical x. I do not think we have to evaluate this at any point, so that's it. That's your answer right here. This is your final answer. So the derivative for the square root of x is the 1 over 2 times the square root of x. And in our later sections, like chapter 3, future lessons, you'll learn to also find the derivative by using a technique, okay, shortcut formulas that we will use to make this process much more efficient. And also it's a way to check your answer too.